So this video will show you how to use the periodic table to calculate the right amount for a reaction. In order to do that, you'll need a chemical equation. Chemical equations show how reactants go to products. And you can think of them as a recipe for your reaction. So I'm going to show you how this works by showing the reaction between magnesium, metal, and iron chloride. So magnesium solid and iron chloride, and I'm going to use iron 3 chloride, which is known as ferric chloride, which is an aqueous salt. First thing that you need to do is write a balanced chemical equation. So in this reaction, I have a beaker filled with ferric chloride. So there's iron 3 plus floating around, chloride, and then I'm going to put in some magnesium metal. So the reaction starts with magnesium solid and iron chloride, and that will produce solid iron, much like the reaction between copper chloride and aluminum produced solid copper, and magnesium chloride. Next thing I need to do is balance my chemical equation. The next step is to calculate the mass of all of our compounds here, our metals and our salts, much like we did in mass conservation. So one magnesium weighs 24 grams, but I have 3 of them, that's 72. 2 iron chlorides would weigh 322 grams. I'm getting these numbers from the periodic table. 1 iron weighs 56. 1 chlorine weighs 35, but I have 3 of them. So you add these together, multiply by 2. That's how we get the molar mass, 322. 2 irons would weigh 112 grams. And 3 magnesium chlorides would weigh 282. You should be able to calculate these molar masses and check that your numbers match mine. And then I can check to make sure I did everything correctly because these should add up to be the same, which they do add up to be 394 grams. Okay, now how do I use these numbers to calculate the amount of something that I want? So what these weights are saying, that if I added into my reaction 72 grams of magnesium, in order for all of my magnesium to be reacted, I would have to put in 322 grams of iron chloride. So the weights are in a specific ratio to each other based on our chemical equation. This also tells me that if I react 72 grams of magnesium, I will produce 112 grams of iron solid. So all these numbers are in a specific ratio to each other, and you can use them to calculate the right amount that you need. 72 grams, 312 grams, 112 grams, those are huge amounts. Those are never amounts that you will use in the lab. They're too large. So we can use these ratios to set up a proportion to figure out how much of something we would need in a number that makes sense. So for instance, let's say I have 0.6 grams of magnesium metal. How much iron chloride would you need to fully react? So this is a way that you can theoretically say, this is how much of one reactant I need if I know how much of another reactant that I have. So based on our chemical equation here, the ratio is 72 grams to 322. So you can set that up in a proportion. 72 grams of magnesium for every 322 grams of iron chloride is equal to the amount of magnesium that I have, which is 0.6 grams of magnesium. I can calculate the amount of iron chloride that I would need. So cross multiply and divide, and you'll get 2.68 grams of iron chloride. This is how much iron chloride I need to react all of my magnesium. You can also set this up for theoretical yield, meaning how much of the product can I make from this amount? Again, it goes back to the ratios here. So 72 grams of magnesium metal produces 112 grams of iron and 282 grams of magnesium chloride. So if I wanted to figure out how much iron can I make from this, I just have to change my proportion slightly. Again, you cross multiply, solve for x, and that will tell you how much iron you can produce. That's a theoretical yield because it's in theory. Your actual yield will be different. And that is how you use the periodic table, masses, and balanced chemical equations to calculate the correct amount.